Hi students, I am going to talk through page 53 to 56 of your packet so that you can make sure that you have these done correctly and understand them. So number 17, the parent function y equals f of x has a global maximum of 0.45. So as soon as I read that part, I thought to myself, I'm going to look at the graph of this. So I made myself a point 3, 4, 5 at 4, 5 way out here. And I knew that was going to be a maximum, global maximum. So the whole maximum and no other maximum or minima, which means it's got to go down from there. Name and classify the maximum or minimum of y equals negative f of x. So if that was what was happening there, negative f of x flips it over the x-axis. So it reflects it over the x-axis. Then that means that this that started like that has now become kind of a right side up u down here. And so my maximum or minimum of that, and I'm classifying it, is going to now become a global minimum, and it's going to be at the point for -5. So it stayed 4 units over, but it went down 5 units. And so that's what my new one is going to be. Number 18. The parent function y equals f of x increases interval -1 to 7. So for this one, I just kind of gave myself that idea from -1 to 7 that this function was increasing. And it says name the interval that the function y equals f of x plus 2 increases on. So I have to understand this piece here, that x plus 2, that plus 2 is on the x, so it's going right or left, and it's always the opposite. So this one is going to be that it moved left 2 units. So I need to take this interval left 2 units both from there and from here. And so the interval that this one's going to increase on is going to be from -3, that's left 2 units from here and left 2 from here, to 5, and that's going to be an open interval like that. Number 19, y equals f of x plus 5 has a y-intercept of 4. So I'm thinking about a y-intercept 1, 2, 3, 4, where it's right there for this function. Name the y-intercept of the function f of x plus 1. So what I did was I said, okay, if this was where that y-intercept was, I really don't care about what the transformation is on this. I care about what the difference is between the beginning to the end. So all I did to go from this first function to this last one is I subtracted 4 from the whole function. And so that means that I'm just going to move down 4 units on the function. So I do the same thing to my y-intercept. I go down 1, 2, 3, 4 units. It becomes here. And then the new y-intercept of this function is now at 0. Again, you can put that as 0. You can put it as 0, 0. Either one would work there. Number 20, if the parent function is y equals x squared, write the equation of the function after the following transformations. So translation, right by 2 units. So we're going to have y equals, and we're going to have an x in parentheses. Right by 2 units means I'm going to subtract 2 because it's going to look the opposite. Put my square on there. Don't forget about that. Vertical compression. So all of our compressions or stretches are vertical, but compression by the factor of 1/2. So I'm going to throw a 1/2 up front here, and a translation up by 9. So I'm going to add 9 to the function. Those are all of my transformations that are happening there. Okay, if we flip to the SAT practice here, again, any of these problems you can pause the video and do, or you can do them first and then come back to the video to see how you did with it. But John runs at different speeds as part of his interval program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So we want to go from increasing to decreasing. So we have increasing, steady, decreasing, increasing, decreasing, increasing, steady, increasing, steady, decreasing. So the only place that we went increasing to decreasing was here, and that was from 40 to 60 minutes, and that is our option B that's there. So number 1 should be B. I'm not going to go quite in order because I'm going to go top to bottom. So question number 3 here. One end of a spring is attached to a ceiling. When an object of mass m kilograms is attached to the other end, the spring stretches to length L centimeters. So that equation is shown above here. What is m when L is 73? So they give me an L value. I'm going to fill that in for L. So that's 73 equals, and just keep the rest of the equation the same here. And then I'm going to solve that for m. So that requires me to subtract 24 from both sides of the equation. That gives me 49 is equal to 3.5 m. And then to get m by itself, I need to divide by 3.5. And I did 49 divided by 3.5 in my calculator, and that gave me 14. And luckily I wanted to solve for m, and 14 was an answer. So letter A was my answer there. If we keep going, and now I get to scroll down a bit here, number 2, it says the table above shows some values of the linear function f, which of the following defines f. So what I should understand is that these are my input values and these are my output values, and I should be able to kind of work through them. So the interesting thing that happens is if I input 1, 1 minus 3 is -2, which works, okay? But if I keep going and I put 2 in, 2 minus 3 is -1, and that did not work. So that means that A does not work. Okay, you keep that process going. So if I put in 1, 2 times 1 is 2, and 2 minus 4 is -2, which is what I wanted. So that one worked. Keep it going. 2 times 2 is 4, minus 4 is 0, not what I wanted. So that one does not work either. Okay, we try the next one. And it's not always the second one that it fails on, but we'll see. 3 times 1 is 3, minus 5 is -2. So again, we got the correct thing. 3 times 2 is 6, minus 5 is 1. So far, so good. 3 times 3 is 9, minus 5 is 4, and 3 times 4 is 12, minus 5 is 7. So C is the one that worked out for all of those, working on our input-output there. Number 4 is interesting. You can read through this kind of on your own, but really all that it asks about is it says that according to the graph, Mark was given a head start of how many yards. So when he started, that was over here. When Paul started, it was here, and when Mark started, it was here. And if I look at the distance in here, this is by 6s. And so Mark started at 18 yards ahead of Paul's 0 yards. And so there was a head start of 18 yards in there. And C was my final answer for that one. If I flip the page, number 5, we have another one similar to the one we just did, but we have these values that are shown for us. So we try to figure out which one works. Again, these are my input values and these are my output values, and we just want to find out what works here. So you can start with any one of them. Let's say I start with the 313. So if I put in 3, 2 times 3 is 6, plus 3 is not equal to 13. So right off the bat, that didn't work. If I put in 3 here, 3 times 3 is 9, plus 2 is 11. So that one also did not work for that. If I put in 3 to the 4, 4 times 3 is 12. Plus 1 is 13. So far that's worked. Put in the 5. 4 times 5 is 20. Plus 1 is 21. We're working. And I put in 1. 4 times 1 is 4. Plus 1 is 5. So all of my input and output values worked. And so therefore C is my answer for number 5. Number 7 over here, the complete graph of the function is shown in the xy plane, which of the following are equal to 1. So making sure we understand that this is my x-axis down here and this is my y-axis. So I'm trying to figure out which of these are equal to 1. So f of -4 means if the input is -4, so input of -4 would be over here. What is the output? And the output is at 1. So this is equal to 1. F of 3/2, so 3/2 is 1.5, so my input is 1.5, my output in that case is also 1, so that one is equal to 1. And F of 3, the input 1, 2, 3 is right here, my output in that case is also at 1. So my answer to this one is D. Actually, all 3 of those options are correct there. Throw a D in there just in case you're looking at that. Okay, number 6, we have a hike going on. So we have a hike that's happening here. It says that she's got her distance from the campsite during a 3-mile hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is closest to the time she finished lunch and continued her hike? So if she stopped to have lunch for about 30 minutes, that lunch time is right here, where there's no change in her distance from her campsite. And then we want to know when she finished having lunch. So finished having lunch should be right in here. Looking at that should be between 1 o'clock and 2 o'clock. And we're closer to the 2 o'clock time. So C is going to have to be our answer there, interpreting that graph. Number 8, Teresa's running on a treadmill for 30 minutes and her time and speed are shown on the graph above. According to the graph, which of the following statements is not true concerning Teresa's run? So we want to figure out which one is not true. Teresa ran at a constant speed for 5 minutes. So constant speed, so speed staying the same would be here. We have a constant speed there and over from 5 to 10, that is 5 minutes. So this actually is a true statement there. Maybe I'll put a T there. Teresa's speed was increasing for a longer period of time than it was decreasing. So increasing speed 0 to 5 here. So there's 5 minutes of increasing. We also have increasing from here to here, which is another 5. So we're increasing for 10 minutes. Teresa's speed is decreasing right here from 10 to 20, so that's 10 minutes, and also decreasing here for another 5, so that's 15. So if we go back to that, Teresa's speed was increasing for a longer period of time than it was decreasing. That's not true, so I'm pretty sure that's the one. Whenever I do these, though, I always check all of them just to make sure. Teresa's speed decreased at a constant rate during the last 5 minutes. So yes, we're decreasing and it's the same slope. So that is a true statement. Teresa's speed reached its maximum during the last 10 minutes. There's the maximum that's right there, and that is in the last 10 minutes of it. So that is also a true statement. So letter B is our correct answer on that one. Number 9, flip into that last page there. It tells us that a complete graph of function f is shown for the what value of x is the value of f of x at its minimum. So we want f of x at its minimum, that's right here, but we want the value of x. That's really important here. So the x value there is at -3. So knowing which values you're given. Number 11, it just says what's f of -1, so that wants me to input -1 in for my x. We have to follow order of operations here. So -1 squared minus 6 times -1 plus 3 all over. And then we have a -1 minus 1 down there. So if I follow order of operations, I'm going to solve this -1 squared, which is +1. -6 times -1 is a +6. Leave that plus 3 in there. And -1 minus 1 on the bottom is a -2. Add what we have on top. 1 plus 6 is 7, plus 3 is 10. Divide by -2 and you get -5 here. So A is my final answer for number 11. Number 10, we have a bouncing ball. So there's that ball bouncing. There's an experiment. It just says after it was dropped, so after the 0, how many times was the ball at a height of 2 feet? So we want to count. There's 1, 2, 3 times that it's at a height of 2 feet. And so we get C for our answer there. Last but not least, snow is falling. So snow fell, then it stopped for a time. When the snow began to fall again, it fell at a faster rate than it had initially. So assuming none of the snow melted, so we're going to take this one off there because that would be the snow would be melting because it would be unaccumulating there. We want to know which one models it versus the time. So and this bottom one would also include is that the snow is accumulated at the same time. It never stopped accumulating. So that one is out of the picture. So we're looking at these two. The accumulation in A, this accumulation is slow compared to this one is fast. And that's exactly what I want. I want it to be faster at the end versus this one is fast and then slow. So letter A is my final answer here for number 12.